All right, welcome to this latest installment of a video about applications of trig functions. And in this particular video, we're going to talk about how can we use two right triangles in trigonometry to solve a problem. And as with any application problem, the first thing you want to do is read the problem carefully. Okay, so this first example, we're looking at a radio tower. And so let's read what we know about this tower. A radio station tower was built in two sections. From a point 87 feet from the base of the tower, the angle of elevation to the top of the first section is 25 degrees. And the angle of elevation to the top of the second section is 40 degrees. To the nearest foot, what is the height of the second section of the tower? Okay, so if you're looking at this diagram, which is great, it's given to you, we can see that there are really two right triangles going on. So we're going to look at those separately and then use what we can figure out about them to solve this problem. Okay, so let's pull these triangles apart and label them with what we know. So we'll take this little triangle over here, we'll take the bigger triangle right here, and then label them with what we know. We know that the bottom of both of these triangles is 87 feet, and then we know the angle measure of this angle on here to be either 25 degrees or 40 degrees. We also know that these are right angles. So let's go ahead and label, and we're just going to assume the right angle. We're given that in our diagram. I did not label them here. Okay, so now what we're going to do is we are going to, since we're interested in knowing this section here, at the top of, well, the second section of the tower, we want to know really what is this dimension, this opposite side of this big triangle, and this opposite side over here. When we put those together, we're going to be able to figure out the section in question. So let's go ahead and label those with some labels so we can talk about them. The opposite side of this smaller triangle we will call A feet, and this opposite side to this larger triangle we will say is B feet. So let's go ahead and use what we know in the smaller triangle to find what A is. We can say that the tangent of 25 degrees will be A over 87, and that means that A will end up being 87 times the tangent of 25 degrees. When I crunch that, I get, well, A is about 40.6 feet or maybe 41-ish feet. Okay, and we can do the same thing over on the right-hand side. This larger triangle, we can say the tangent of 40 degrees is B divided by 87. And so B is equal to 87 times the tangent of 40 degrees, which we can approximate as about 73 feet. So let's kind of mark up our initial diagram here. We can say that the height of the entire tower, we call B, is 73 feet. And the height of the first section of the tower is about 41 feet or 40.6 feet. So all we need to do to find X is to subtract A from B. So X is equal to B minus A. And we can sub in our values there and find that X is equal to 32.4 feet. And we would round to the nearest foot as it says to do. So X would equal 32 feet. Another example we have is a couple of rabbits. So that's especially appropriate for Easter time if you happen to be watching this video around Easter time. Rabbit A and Rabbit B are sitting 36 feet apart. Between them is their home, and that's a rabbit hole that's directly beneath a bamboo tree. So from point A, the angle of elevation is 52 degrees, and from point B, the angle of elevation is 48 degrees. We want to find the height of the tree to the nearest tenth of a foot. This one is similar, but it's a little trickier, but we're going to set it up kind of the same way. So let's go ahead and Okay, so we've got these two right triangles. Now, the one thing that we don't have is a length for any one of the sides of either one of the right triangles. We just know that that entire portion on the bottom is going to be 36 feet. So what we're going to do is we're going to assign a variable to one of these sides, okay? And we can use either one. It doesn't really matter. I happen to choose the left-hand side, and we're going to call that our variable. We're going to call that x here. And then if this is x, then the bottom leg of this right triangle and the larger triangle will be 36 minus x, because together they would have to equal 36. Okay, so we're going to need to use that relationship. Now let's go ahead and pull our triangles apart and label them a little bit with what we know. So on that smaller triangle, we can say that that's x feet on the bottom leg, and the height is h over here. We can say on the larger triangle that the height is still that vertical leg, and the horizontal leg is going to be 36 minus x feet. So with what we're given, the obvious trig function that we would use would be tangent, right? Because we have an angle measure and we've got stuff labeled on the opposite and the adjacent sides of each of those triangles. So let's go ahead and see what we can do with tangent here. Let's say the tangent of 52 degrees is equal to h over x. Well, okay. Now what do I do? Because I've got two variables. Well, what am I really interested in? Well, that's a tricky question, right? Because, okay, so we're interested really in the height. So let's go ahead and solve for h and see what happens then. Okay, so if I solve for h, I would just say that h is equal to x times tangent of 25 degrees. It doesn't really help me all that much yet. Let's go ahead then to the other side and do the same thing. We can say the tangent of 48 degrees is equal to h divided by 36 minus x. And then if I multiply both sides by 36 minus x, we would have the tangent of 48 degrees times the quantity 36 minus x is equal to h. Okay, so notice that I've got tangent of 48 times 36 minus x. That's a quantity. I need to distribute that tangent to both pieces. So 36 times the tangent of 48 degrees minus x times the tangent of 48 degrees is equal to h. Now notice I have two expressions that are both equal to h. And if they're both equal to the same thing, I can set them equal to each other. So I can say that x times the tangent of 25 degrees is equal to 36 times the tangent of 48 degrees minus x times the tangent of 48 degrees. Okay, now what do I do with that? Well, you see you've got a couple of x's on both sides. It's really combining like terms at this point. We want to bring everything that has an x to one side of the equation and everything without an x to the other side, okay? This is really no different than 5x plus 2 is equal to 7x. You're going to move the 5x so it's over with the 7x. The only difference here is our coefficients, or what is being multiplied by x, are trigonometric expressions. So let's pull this negative x times tangent of 48 degrees over to the left-hand side. All right, so now we have x times the tangent of 25 degrees plus x times the tangent of 48 degrees is equal to 36 times the tangent of 48 degrees. Okay, making progress. All right, so now what we want to do is factor that x out of the left-hand side. Treat it like a GCF so we can isolate it. So we would factor out an x there, and then we would have x times the quantity of tangent of 25 degrees plus the tangent of 48 degrees is equal to 36 times the tangent of 48 degrees. Now I would isolate x by dividing both sides of the equation by this entire expression. And when I do that, I get x is equal to the quotient of 36 times tangent of 48 degrees divided by tangent of 25 degrees plus the tangent of 48 degrees. Then I would want to take my graphing calculator or scientific calculator for that matter and get an approximation, because what I'm finding really is this dimension right here, right? Because I'm solving for x at the moment. So let's use our technology and get an approximation. And you should get about 19.27 for x, so that's going to be 19.27 feet. Okay, but that is not the answer to the question that's being asked, because we are being asked to find the height of the tree. So what we're going to do with this 19.27 is we're going to take it and sub it back into this equation, because now I can multiply that 19.27 times the tangent of 25 degrees and achieve the value for h. So when I do that, I get that h is going to equal about 21.4 feet. And that would be our solution to this example. For the next video on applications of trig functions, we are going to be talking about how do we use bearings. See you then.